Hello everyone, welcome back to my channel. Today we are going to explore on how we are going to solve a real world problem for KNN Regressor, and we are going to understand that in this video, and by end of this video you should be able to in a position to completely relate on how the KNN works in both classifier and regressor, because the classification I have already explained and the regression I am going to explain you right now. So stick to this video till end and let's start with the topic. Let us start with our k nearest neighbor problem or the regression issue. So we are going to explore on how we are going to predict the MPG or the mileage per gallon that that we are going to predict, and we will understand. First we have to understand the problem statement, right? What exactly is the target variable? What are the variables, independent variables involved in that? So we will explore everything. So the first step, what we are going to do, we are going to import our libraries or base libraries, which we are going to tell. Those are our matplotlib, pandas, numpy and seaborn. So I am going ahead and running them. Then we are going to understand the attributes or the variables which are present in this particular data set. So we have MPG, okay, that's our target variable. So it's a continuous variable and it's miles per gallon, right? Or the mileage which we are talking about for every vehicle. Then cylinders, it's a multi-value discrete, right? Discrete means, you understand, that means the values are not continuous here. And displacement, continuous variable, it's a measure of engine size and volume. Then horsepower, engine's power output, weight of the car. Then acceleration, it's a rate at which the car can increase the speed. Model year, that means the year when the car is getting built. Then origin, we have three different values here. It's a discrete, right? One, if you'll see one as a number in that, that's going to be American, 2 for European and 3 for Japanese. Then car name, it's a string variable, okay? So we found we have these features which are directly associated to find the MPG. And let's explore our data set first for that. So we have already, loaded our dataset. Now let's see the head part. So if you see that we have, like, this is how your dataset looks like. And you should observe each and every value carefully here from now on. So here you can see the MPG, we have, all the values are in 2 digits. Cylinders, you can see that we have, we can see 8. Then displacement, we have, different values which are in 3 digits. Horsepower, again 3 digits. Weight of the car, it's in 4 digits. Acceleration, it's in 2 digit. Model year, that means it's a year of, or when we are saying that it is 70, that means it's 1970. Then 1, in origin 1, that means wherever we are seeing 1, that is US, and like that we have other 2 features, right? 2 for European and 3 for Japanese. And these are the car names. Then we will see info. This is the info. And from this info, what we are understanding? We are understanding that we do not have any null values. And we have 3 different types of data types present in this: int, float and object. And we have 398 rows present in this. Then this is the descriptive statistics part. Here we can see mean, standard deviation, the minimum value and the maximum value. So we will take one, at least we will take our target variable and we'll see what exactly are the values present for them. So we have mean value, which is 23.5, STD 7.8, minimum 9. Then 25% it is 17, 50% it is 23, then 75% 29, and the max. So what are these guys? What is 50%? It's median, right? 75% it's a quartile, quartile 3, quartile 1. So these values we understood now. Now what is the next step? We have to know, or we have to verify whether we have any null values present or not, right? So for that, we know what we have to do. We can use is null or is NA. So we are able to find out that we can see all are 0. 0 means we do not have any null value. Because what exactly it is doing, if we use is null, it is going to break that whole data set into true or false. So it will just count the total number of false and it is going to give you the output. And then we are going to see, because we have discrete variables present in this. So for that we can see whether we have the wide range of discrete variable or we have limited range of discrete variable. All these things we are going to explore. So we have car name, and I can see that car name, this more specifically, people are not using same car, right? If you see from different households, they are not using same cars. Cars can can be different from different person to person's perspective, and there are several models related to that. So let's explore that. So yeah, we have I think around 305 different car models or car names present in this dataset. So the highest for Pinto is present 6 counts, and these are the highest counts, and the rest all are present in a single number. Then we will see whether we have any duplicates. We won't be having any duplicates, guys, because when duplicate part will come when we have null values, and when because of those null values, that means there is empty rows, right, or empty columns in that. Then data.columns, we are observing what are the columns, then ahead. Now, what is the next step, guys? We have covered our data cleaning part, and what is the next step we have to do? We have to explore, or we have to understand the behavior of different features, right? Because we know these are my features. From these columns, we got to know that we have different features. Now we have to explore them. So we have univariate, right? We have, we know that which are continuous, which are discrete. For continuous, we are going ahead with scatter plot. We are going ahead with bar plot, like that. To know the behavior of single variable or the discrete variable, what exactly we are doing, guys? We know the values by using value counts, and we know the plottings by using count plot. The same thing we are going to do now. So let's see that. So first count plot I am taking from cylinders, because cylinder I have, from the data set or from the description, I can know that is a discrete. And for discrete, I want to know what are the different categories present in this, right? So I have 5 categories present in this. So out of that, the highest cylinders or the highest cylinders vehicle is present as 4 cylinder, right? You can see this is the highest, around 200 plus count is present. So like that we have understood that. Now what is the next point, guys? We have origin, right? Origin means we have 3 types of origin, right? And we can get to know by this color coding. So the same thing I did it. So we have 3 origins, 1, 2, 3. So I can see that most of the vehicles are sold or are used in US, or like you can see that 1 means US, 2 means I think it's some European countries, 3 means it's Japan. Then I can understand the outliers present or not from box plots, right? So with this I can plot different box plots at a time. All what the box plots are going to be on my numerical variables, right? Because for that reason I have taken my count plot already, so that you should be able to understand the discrete variables first, then we are going ahead with our continuous. So from this data set which I am seeing, it looks like we don't have any outliers present. The data looks good, right? Then what is the next step? We can go ahead and do our feature engineering. What we have to do? We have to convert our columns or our discrete or what I can say categorical columns to our numerical columns. So for that I can use my pre-processing, right? So for that I have done that. I have already pre-processed my car name, and now I can see that my car name is in numerical. Now we will understand the heat map, right? Heat map is for what, guys? It is going to give you the correlation between different variables, right? So here, what is my target variable? So in how you will read heat map, we have to get the target variable, and as we have to understand the relation with the target variable with other variables, we can explore that here. Because MPG is our target variable, so the same thing we can come here and see. So you can see that 0.78 is for cylinders. Then displacement, I think minus 0.8 is my displacement. Their weight is my minus 0.83. Then positive relation is there with acceleration. Then we have model year. Okay, model year is also there, which has positive relation. Then we have origin. Origin also is having some relation. Then we have car name. Car name is bit low as a relation. However, if we see the correlations, either positive or negative correlations are present. So these three features, cylinders, displacement and weight, are negatively correlated. However, the others are positively correlated, and we will explore that with reg plot, because reg plot is going to give you the exact reg line, how it is going through each variables. So the first one, we have cylinders and MPG, you can see. And we already saw that it is negatively correlated. And if I'll take you to the whiteboard, how it is positively and negatively correlated. If this is my regressor, this is my data set, this is my X, this is my Y. And here I have taken my cylinder, right? And here my MPG. And this is my line, right? This is my regressor line which I am getting, and these are my different points. So this is my positive correlation, because my line is going towards positive direction. And if I'll again draw it, this is X, this is Y. If I'll again draw it, now my line is like this, right? And these are my different points. That means my X is negatively correlated to Y. Simple, right? This is my negative correlation. That's it. That is how your positive and negative correlation looks like. So here we have seen that this is my negatively correlated. Then here, if we'll see my displacement and MPG, this is again negatively, because we have seen negative symbol over there, right? So negatively correlated. And if we'll see weight and MPG, this one is also negatively correlated. Yeah, we can see that from the plot. Acceleration and MPG, this should be positive, so you can see, right? Then model year and MPG, let's see, yeah, it is also positive, so we can see that. Origin and MPG, this is also positive. We saw that already from the correlation table. Then car name and MPG, this is also positive, but slightly positive. It's not highly correlated, that means. So we understood our correlation with different features. We understood the regressor, how these regressor lines are coming up. Now what is the next step, guys? We have to train and predict from our model, right? So for that, what do we have to do? We have already imported our base libraries. Now we are going to import our important libraries, or the sklearn libraries, sklearn sets. From F is gone from here. Okay, so what are the first steps? We have to get our train test split, right? And all cross validation and your hyperparameter, everything is present in what? We have model selection, and that is present in sklearn. So we here from model selection, I am importing my train test split, cross validation score, and grid search CV. And one more important thing I already told you guys, in case of classification, there is a high chance of the model is getting overfitted, because here we are not usually we are not, in case of classification issues, we are not going ahead and there is no continuous reading like we in our regressor problem. We are finding out coefficients, and those coefficients are again on continuous variable basis, right? Here it is not. Here, there is a high chance that the models are going to be overfit, and for that, it is always better practice to scale the values or to scale down the variables to a single scale, and for that we have to pre-process the data. So pre-processing is an important concept when you are working with classification problems. Then we are going ahead and getting our k neighbors regressor. For classifier, what is that? K neighbors classifier. Then we are getting our metrics. We have used mean square error and R2 scores. So let me run everything. Then I'm dropping my target variable from X and I'm getting my target variable in Y. So I'm going ahead. While working, guys, what I did, I found there are question marks in few of the columns. If you'll encounter these kind of issues, because what I did when I was trying to train the model or train the model with train test split, I was getting that we are not able to proceed and we have few string variables present. We cannot convert them. So what I did, I thought of checking it, and when I checked the error message, I found that there are question marks present. And in real scenario or in your projects, you must be getting these kind of scenarios. We don't know, right? Because those data are in hidden format. We cannot see. This is only 398 rows. You will be getting the data sets of lakhs of rows, millions of rows. How you will deal with it? You can go ahead and find it like this. So here I am able to see that I have a question mark symbol in my error message. So what I did, I was trying to find this question mark from my X, because X is my data set to check. So you can go ahead and you can just type is in. I wanted to check whether this question mark is present in my data set or not. Then if I'll run this, then what is the next step? Yeah. So I am able to see that I have these many rows where my question mark is present, right? Then I am replacing that question mark with NN value. Then what I'm doing, I'm using my impute. We have imputer, like simple imputer in sklearn present, right? So I'm going ahead and doing that. Then I'm just telling that, okay, my missing value should be np.nn because I have already replaced it and I wanted to replace with mean. So I did it. Then after that, I am going ahead with my fit and transform, right? Then I am going ahead and I am just scale it down all my values. Then I am going ahead and training my data with train test split. So x train, x test, y train and y test. These are my this is my scale down variable, x scaled. Then y test size I have taken 0.2. Random state 42. That's a sweet spot, guys. You should always use that. Then we are going to build the regressor. So here the main part will come and we will explore that. So here what we have done, we have initialized our KNN with k nearest neighbor, k neighbors regressor, and my neighbors or the k value which we are talking about, I have taken as 5. Then I'm fitting my model. What I'm going to do for fitting, I have to train my data. So I have taken my x train and y train. If you want to know the shape of x train and y train, we can do that. X train dot shape, you can just get like this. So I have 318 rows which have been considered, or the data points which they have to, it has been considered. Y should be also the same number, guys. Okay, so we have done that. Now I'm going to go ahead and predict my output. So for predicting, what do we have to do? We have to test the data. I have to run this. Then after that, I have to run this. Then after everything, what we have to do? If you want to see the predicted output, guys, you can just do like this. Y predict dot head. We'll do this. Okay, if I want to know. Yeah. We cannot see the head directly because we have to convert that to data frame. So just you can see the shape right now, guys. I mean, my shape of the Y predicted output or the data it has predicted is 80. And now one thing will be crossing in your mind. We already have data what you are predicting here, right? exactly what we are doing here. We have actual data, right? Now we have to know whether my machine, if on this step, exactly on this step, we have to know whether my machine has predicted those, like by considering those data, whether it has predicted correctly or not, or the value should be near to those actual values, right? And to determine that, we have these things, that we have different error handling or the evaluation metrics, which we have in regressor and in classifier, both we understood. Now if we'll see this, we are getting the mean square error as 5.82. That means there is a 5.82 value difference overall throughout your those 80 outputs, or the 80 actual value. Suppose the output you are getting 25. That means I am getting plus or minus 5.82 throughout our output, or there is error value present, or that means it has predicted with that much difference. Then RMSE is just a root square of MSE, guys. Then R2 score, I'm getting 89%. And because I have some error, right? I have some error of 5.82. My model is not 100% correct. That means it is just 89% of accuracy my model is giving me. Then the same thing we can get it, or we can achieve, because we have done everything. Now we will do it with my k-fold validation, right? Cross validation, or which you can say cross validation. How we are doing, guys? We already know, because cross val score is the one where we are initializing everything at once, correct? So we are getting our model. We are giving input as a independent variable, then dependent variable. Then I'm telling my CV or my cross validation score is 5. Then my scoring technique is R2. Then I'm going to get my scores and my scores leads. Let's see that what we are getting. So these are my different variables, right? These are my different different outputs based on my R2 scoring, and these are my different folds. This is my first fold output. This is my second fold output, right? This is my third fold output. This is my fourth fold output, and this is my fifth fold output. Because I have 5 folds, I'm getting 5 different scores, right? Then my mean score, if I'll get, I'm getting 0.67. It's considerable, but still it's low. Then we can use hyperparameter, because in one model I am going to show you everything. So that's what my plan is. So I am showing, or I'm going ahead with hyperparameter tuning as well, with using grid search CV. What is the first step, guys? We have to initialize our hyperparameters in one place or in one dictionary, right? So here for grid search CV, we are going into param underscore grid. What we are doing, we are getting our neighbors, right? And I wanted to try with 1 to 20 range. Then weights, like for KNN, we have to get weights, right? I have already shown you during our classification what is the difference between these two. Then metric. Metric means distance, either Euclidean or Manhattan. Then I am initializing my grid search CV, right? And this is my k neighbors regressor, then param grid, then CV, then scoring. Either this should be negative mean squared error or mean absolute error, like that. Then I am fitting my grid search CV. Then after that, what is the target we have to achieve? I have used some 5 to 6 different hyperparameters in one model, and I wanted to know which is the best parameter out of it, and what is the best score I'm going to get. So with this, it takes some time, yeah. So with this, I'm getting my best params, or the metric which has been used throughout this whole process is Euclidean. My neighbors worked with 4, like if I'll take 4 different, like 4 neighbors or 4 points, then I'm going to get accurate output. Then the weights, it is distance. Then the best score, I just need to use minus here. And the best score I'm getting is 11.269. That's the mean square error. And the top, what we got, guys, here, we got, where is it? Yeah. So if we go directly, I got 5.82 mean square error. So here I'm getting, that's the best score, 11.26. And Now we are going to understand how the difference between actual and predicted trend, how the trend is coming up. So you can see our model is predicting better, right? I mean, the orange one, if you see, the orange one is, your predicted, and it's almost nearing to your actual, which is a good sign. And if we'll see the residuals, predictors and residuals, this is how it is, right? And if we'll see the distribution of error, you can see my errors is what? Y actual minus Y predicted. And this is how your histogram looks like for that. It's a Gaussian curve how you are getting. So this is how we can achieve our regressor or k neighbors regressor issue, or the problem we are solving with k nearest neighbors regression. So we will meet during our next video. Thank you. That would be all for now. We will cover support vector machines concepts during our next video. And if you really like the contents, guys, please hit subscribe and like, share your comments, share your feedback, share this channel link to all your near ones and friends, and hit the bell icon while subscribing, guys, so that you will not miss any kind of latest updates, because again and again I'm telling that contents are going on regular basis. You should not miss them, and I suggest not to miss any videos, because these are very important concepts and mostly asked questions during interviews. So see you till next time. Bye. Take care.